Well, I know it's been quite a while since the last video that I posted, and thought it was about time I kind of showed that the channel wasn't dead and show what I've been up to since the last video. Because I kind of set the Razor Crest aside mainly because, well, I wanted to see what the round 2 AMT version was like, and I really, again, was unfortunately unimpressed. I like the Revell better, but we're not going to get into that. We're talking about what I've been working on, which during the summer months, being as wonderful as they were here, probably the nicest summer I can remember, I have this thing about garage sales and yard sales, and I love going to them and finding old radios, AM radios. Not too much on the FM because that's a little bit too new for my interest. I like the old AM portable tube radios, even though I have a bunch here. Let me take this off and get this. A bunch of AM transistor radios down here, or AM and FM shortwave, things like that, that I've picked up at yard sales. I've got a big Zenith transoceanic, the first year that they went solid state. It's AM shortwave, not FM, just to show you how early it was. I think it's 50, it was the latter part of the 50s, but it was the first transistor version of their transoceanic radio. But what I had been really interested in are the battery-powered tube radios. And I have a couple of the Motorola's, which I like the Motorola's because they have the antenna built into the handle, and you can rotate the antenna to improve the reception without having to change the direction of the speaker. I've restored these, but I wanted a way to power them which didn't require the two batteries that are necessary. Tube radios, for those people out there that don't know, and this is kind of a random video for those of you out there like myself that restore old radios. The tube versions require at least 2 batteries because they need the low voltage, usually about 1.5 volts, for the filaments in the vacuum tubes, and they need a higher voltage for the tube's inner workings, and that usually on these is 67.5 volts. On the Motorola, it's 90 volts, and I wanted to, again, be able to run these things off of a single battery, and preferably lithium ion. So I got a hold of these, which are really for these smaller AM radios, because these are the smallest AM radio that were built by the Japanese in the later 50s, or the mid-50s to the later 50s, using conventional tubes. Now there are smaller ones, this is even smaller, but there are smaller ones out there, but they use a special flat, kind of an oval tube. These are standard 7-pin, let's call them conventional tubes, and those are what I lean towards. But the problem is again, the common practice is for the higher voltage, people putting together a stack of 9-volt batteries, which, hold on for a second. You can find people online that sell these. This is a 90-volt battery that is referred to as reusable, but that's only because what they use are a bunch of 9-volt batteries. And there you go, they stack up there. That can get expensive, and the lifespan isn't all that great. So I wanted to get to something that I could recharge, because even if you got 9-volt rechargeables, that's pretty expensive, because each one of those are what, $7-8, if not more. So again, what I wanted to do was find a single battery solution, and so that's what I've been kind of working on for the last couple of weeks. Is I stumbled across these, which this is a high voltage boost regulator, and it goes down. I don't have a data sheet in front of me. Oh God, what a knucklehead I am! I believe it goes down as low as 11 volts or 12 volts, and all the way up to 390 volts. Of course, you have to trade off the voltage for the current, because you can't have both. So at 390 volts, I don't think the output current is more than a couple of milliamps. I've not tried it, and you go looking for specs on these things, and it's elusive at best. Matter of fact, I couldn't find any schematics or anything, so I had to kind of reverse engineer these. But this was to take care of the high voltage, and at first these, which is just a step down, was going to handle the low voltage. The problem is these Japanese circuits, is an excellent design, but they have something in them that, and again, I should have the schematic. They have a line that comes off of the grid of the amplifier tube down to the high voltage battery, negative to ground, and they put in this 470 ohms. You can see this range vary by a couple of hundred ohms on other manufacturers, but all the radios of this design from Japan have this resistor to ground, which means that your filament voltage and your high voltage have to be isolated. You can't have a common ground, which is most unfortunate. I'm not sure if this is a grid bias resistor or if this is a current limit for the high voltage, so you don't blow out the tubes. Hopefully somebody out there much more knowledgeable than I can answer that question. I kind of look at it and the way it's tied in there as a grid bias on the amplifier tube. So again, if somebody could answer this question, I'd really appreciate it. But it kind of forced me to go from a much simpler, and I don't have any of the original circuits because I had to tear them apart and go the different approach. It would have been much smaller, basically, and I'm getting so off kilter here. The need was isolation between the high voltage and the low voltage. And all of these boost regulators, the smaller ones that use an inductor, it's understandable why. But when you get into these ones that actually have a true transformer, I don't understand. I mean, I'm hoping it's not just because they were being cheap. The feedback circuit here is not isolated. So even though they went to the expense of a transformer, the input and output, primary, secondary, are tied together through the feedback circuit. Annoying as hell, because this is a beautiful circuit that does exactly what I need to do after I extensively modify it, but still everything I need it to do except be isolated. I had to go out and find these. This is I got all of these off of Amazon, and then turn around and bought a couple of more of these from Walmart of all places. And this is a 5 volt step down supply with an optical isolation. So this is isolated, and this ended up being, in this version here, this is my 1.3 volt supply. Much bulkier than I originally wanted, and much bulkier than the original, which was going to be just this with this, and is this in the Motorola's, not in the smaller Japanese versions. But it's a minor inconvenience, because these things are gorgeous. I mean, they're tiny relative to vacuum tubes, and I was able to pick up four versions, 2 of the larger chassis and 2 of the smaller chassis. And this one's kind of giving me fits as far as how I'm going to fit it in there. This version, I was able to put the circuit into these boxes, which I made that are not much larger, or no, the same size as a D-cell, except for the square corners protruding, but that's not going to be a problem when I drop it in. The A battery boxes on all of these radios, unfortunately, are damaged from leakage, so they're going to have to either be rebuilt, or what I'll probably do is remove them, lock them, or store them, so that my modifications aren't destructive and could be put back for those purists if I ever decide to sell these. But for me, this can just drop right in. And I'll probably do another video focusing on just what I'm doing here. This is kind of a general video of what I'm doing, and I'll get specific later on if this video even gets any views. The final version, after I cut down, because see what I did was remove the heatsink, because fortunately the amount of current that the high voltage draws is relatively low. It's I think 20 to 60 mils at best. It's the filament circuit that draws the most current, and even that's only 250 mils, quarter amp. So what I would do is pull the transformer off, the heatsink off, and start cutting down the board as far as I could without losing any of the active components. And I'd remote the transformer and actually reduce the size of the capacitors even further from what was originally supplied on the board, tied in the 1.5 volt supply up on top, and then used this electronic push button circuit from Pullilalu. And the advantage to it is it draws very, very little, I mean like microamps of current when the unit's off, so I can leave the battery attached without too much risk of over discharge, which you never want to do on a lithium battery, whether regardless of its technology. So, and there's protection circuit built into these that guarantee you don't. So here, let's hook this up. Oops, where you're at. Okay. And so what you do is simply push button start and stop, and this will be sealed up and put into the radio in a fashion that I'd be able to get to it for long-term storage, so I can disconnect the battery. Sorry about the helter-skelter nature of the video, but that's why I don't like doing them. This is where I'm at with these. I'm going to do another video just showing all the projects that I have and waiting, like I need to start another one. Oh, another thing I had been waiting for was this, which is a function arbitrary waveform generator that I needed for doing the alignment on the IF always good, because over the years these things tend to drift and you want to dial everything in. This is what I'll be using to create my intermediate frequency that I can compare and align these two. There's videos and text online that describe how to do this. This will be a non-contact coupling, and basically just an antenna that'll be close by that I can listen to or watch on the scope and see when I get the maximum amplitude out from my radio matching the input frequency. So let me end this because I'm all over the place, and I'll do specific videos as I recap these, which is something, again, I should recommend anytime you buy old electronics, 50 years or older, and maybe even newer depending on where it's from and the type of capacitors it had in it. Replace at least the electrolytics, but you can have problems with the paper caps, the micas, not so much the ceramic, but still I'll be doing a complete recapping of all of these before I consider them done. But yeah, this took me a while to get it down small enough to fit it in basically as small a box as I could and still have room for whatever heat might be generated. You know, at a quarter amp, the low voltage supply might get a little warm, but I'll watch that with my IR camera. So anyways, I haven't died. This is just something that I'm going to be working on in the colder months, but that lends me to the next problem, which is my other task that I had set up for this winter, and that's these guys. And I'm going to do a separate video here in just a second, focusing on projects that are outstanding and hopefully going to get to after the first of the year. So that's it for this one. I'll see you in the next video. Bye.